Have you ever wondered how a simple thought, just an idea in your head, turns into a real working program on your computer? Well, today we're going to pull back that curtain. We're going to see exactly how it's done using one of the most important programming languages ever created, C. All right, let's get right into it.
So how does that happen? It's a journey, really. Every single piece of software you've ever used has gone on this trip, from just a spark of an idea to a set of instructions that a machine can actually understand and follow. Let's trace that exact path together.
No matter how huge or complicated a program is, it always starts with one thing, a problem that needs solving. So for our purposes today, we're going to tackle a simple classic. We're going to build a basic calculator that just adds two numbers. That's it.
Now, before we even think about writing code, we have to do the most important step. We have to make a plan. And in programming, that plan is called an algorithm. It's the pure logic. The best way to think about it, it's like a recipe for your computer. It has nothing to do with a specific language yet. It's just the step-by-step instructions. And here is our recipe, our blueprint. Look how clear and specific it is. Every single step is laid out in perfect order. Get the first number, get the second one, add them together, show the answer, and then stop. There is absolutely no confusion here. And that precision, that's what lets a machine, which is fundamentally pretty dumb, produce a smart result.
So, we've got our blueprint. Our logical plan is all mapped out. The next big challenge is, how do we translate this recipe into a language that the computer can actually understand and run?
For that translation job, we're gonna use C. And it's really the perfect choice for this, because C is kind of like a bridge. It sits in this sweet spot, super close to our human way of thinking, but also incredibly close to the machine's world of ones and zeros.
Okay, so to hold on to our numbers, we need to set aside a little bit of space in the computer's memory. In C, we do that using things called variables. The whole labeled box analogy is a great way to start thinking about it. But in C, it's not just about the name of the box. The type of box you choose is critically important.
And this, right here, gets to the very heart of C. You can't just create a box. You have to tell the computer exactly what kind of stuff is going to go in it. Are you storing whole numbers? That's an int. Need decimals? That's a float. This strictness isn't to make your life harder. It's to force you to be super efficient and precise about the memory you're using. So now you can see the direct one-to-one translation. Our instruction to display text becomes the printf function. Our step to read a number becomes scanf. And of course, add the numbers becomes sum equals num1 plus num2. See? Every line of code matches a step from our original blueprint. But let's be real. Programs aren't just simple recipes that run from top to bottom. Their real power, what makes them so incredible, is their ability to make choices and to do things over and over again. This is the secret to automation.
So how do we actually give our code a brain? How do we get it to make a decision or handle a repetitive task? Well, we've got two fundamental tools for that. Conditionals for making choices, and loops for handling repetition. Think of conditional statements as forks in the road for your program. The if-else is your classic choice. If one thing is true, you go down one path. If it's not, you go down the other. Then you have the switch statement. That's more like a menu at a restaurant, perfect for when you have a whole list of specific options to choose from. Now, for doing things over and over, we use loops, and their purpose is simple, but it is so profound. Automation. Instead of you writing the same line of code 1,000 times, you write it once and just tell the computer how many times to run it. This is the real engine of computational power.
And you gotta know which loop to use, right? A for loop is your best friend when you know exactly how many times you need to repeat something. Like, say, counting from 1 to 10. But a while loop, that's for when you don't know. It just keeps on going until some condition you've set is no longer true. Okay, so we've got our logic figured out, and we've written our C code in a text file. But how does that plain old text file become a program you can actually click on and run? Well, for that, you need a special set of tools. It really just boils down to two key things. First, you need an editor, which is just a special program for writing your code. And second, and this is the really important one, you need a compiler. So the code itself is just plain text, and you write it in a text editor. Oftentimes, it's a specialized one, like V or Vim. They might look old school, but they are built for pure speed, using keyboard commands for everything, like hitting I to start typing and then typing /qd to save your work and quit.
And now for the most critical step, the translation. The compiler, in our case we're talking about the famous GCC, is the tool that does the heavy lifting. It reads our human-friendly C code and translates it into the raw binary instructions that the computer's processor can actually execute. That command you see on screen, that's what kicks off the whole process.
You know, these tools actually tell a really cool story about how programming has evolved. You had old school compilers like TurboC, which were proprietary, expensive, and locked to one platform. And then you have something like GCC, which is totally open source and available on basically everything. That shift from closed, walled-off systems to open, collaborative tools completely changed the world of software.
So there we have it. We have our core concepts, variables, logic, loops, and we have the tools to bring that code to life. Now, these might seem like really simple, small building blocks, but trust me, they scale up in incredibly powerful ways. And it's worth just pausing on that for a second. Think about the most complex video game you've ever played, or even the operating system on your phone. At its very core, it's just a gigantic, intricate structure built from these exact same simple ideas: storing some data, making a decision, and repeating a task. And just look at how these basic blocks can scale up to build real-world applications. A system to manage student grades, a tool to manage an entire library's inventory. These are not simple little programs, and yet they're built by combining the same fundamental concepts we just walked through, just in more complex and creative ways. And that is why C is still so important today. It's not just another language. Its whole philosophy of being simple, powerful, and close to the hardware has influenced pretty much every major language that came after it. Learning C is like learning the grammar of how modern computing actually works. So at the end of the day, programming isn't some kind of magic. It's really just the art of breaking down a big, messy problem into a series of tiny, perfectly logical steps. You've now seen all the fundamental building blocks you need to get started. So the only question left is, what problem would you solve first?